Yeah, start.
Yeah, let me drag it. Okay, sounds good. So first question is like you have to split array in such a way that with same average. So you are given an integer array and you must move every element of A to either list B or list C, and B and C are initially empty. Return true if and only if after such a move it is possible to obtain the average value of B equal to average value of C, and both of them are initially empty. So like these two arrays, if you add them and divide by 4, both of them are equal. Yeah, and your length of A will be in range 1 to 30, and AI will be range from 0 to 10,000. Yeah.
Well, okay. So in this case, if you look at the explanation as well as the problem statement,
Okay.
what they are trying to say, the problem statement is slightly, very different. He's asking us to split the whole integer array into two different lists, correct? And at the end, they are also saying, you find an average between both of these lists, and the average should be same. So if you look at it, it seems like even if you do average on the original array, it should also be the same, right? So you're not
Oh,
required to split the array, correct?
I didn't get. Uh,
See, if you look at the explanation,
yeah,
what it says, yeah,
got it. Yeah. Since
yeah,
the average are equal, so if you club them, so average of the entire array will also be same.
yeah, it has to be same, correct? Yeah.
Yeah, got
So yeah, I don't know whether it is on purpose or
it.
maybe if they would have said, okay, we are actually splitting them and one average is greater than the other, then the problem would be different and it might be more complex, right? But if you look at it, I
No,
would say like, I'm sorry, yeah, go ahead.
no, I'm saying you have to find that whether you can split it into two parts or not, right? There could be possibilities that you might not be able to do that.
Well, okay, is that the intent? The intent is only actually to find an average.
No output true they are giving, right? Whether you are able to split into two parts or not with same average, right? That's why output is a boolean value, isn't
Okay,
it?
see, okay, so the thing is, okay, what they are trying to say is you find an average, okay,
Mm.
but only thing, the whatever input array, okay, it should not be an empty. See, why they're
Yeah,
trying to ask us to split, it might be
yeah.
if you are actually splitting, it's not going to be exactly two splits, exactly of same sizes. It can be of any size, correct? So as long as we are getting an average on both of the leagues, they are nowhere saying that both of the leagues should be of the same size,
No, it need not be.
right? So
Yeah,
we can have only two elements also of the same average, and in this case, in the example one, what I can do is I can pick 1 and 8 as one list, which will be average 4.5, correct? And if
yeah,
I remove the rest of the ones which are leaving 1 and 8, so it is 2, 3, 4, 5, 6, 7, that also average will be 4.5, right?
yeah. That could be one another answer. I mean, another set of arrangement.
Yeah. So
Yeah.
you can actually form it anyway. So as good as it is, like you go through the whole array and find an average of that array. So that average should always be greater than 0, because if it is 0, then it is an empty string, empty character. That is the way I look at it. But what you say also is fine. So you should have, at least you should be able to break it into two sub arrays, or
Mhm.
two subsets, whatever it is, so the average should be the same,
Yeah.
correct? So they are slightly actually asking us in the problem statement to create two different lists, but yeah, the relevance here is only they should not be empty, right? So if you even have a single element, I'm not sure whether, I never tried with that test case also. So if there is only one element in a, maybe then it is not allowed. Yeah, that
Mm.
might be a case, right?
Yeah. Because initially both the array are empty only. I mean,
No, actually, yeah, if it is one, they return false if it is a single element, because you can't break it into two. Okay, then
Exactly.
that makes sense. Yeah.
Well, if you have a
This
single element and if that element is 0, would it work?
If
The
you have
average is
zero,
0 and empty,
yeah, yeah. So let me try,
maybe.
but I think it will give false in that case. Yeah, it gives false. So any element or single element of any value, okay, it will return false. So yeah, for that reason it makes sense. Yeah, actually, yeah, the length is 1 to 30. Yeah, right.
one,
Mm.
or yeah, you can
So,
visual. Yeah, go ahead.
No worry. Yeah.
Yeah, I'm saying we can visualize this problem in a subset problem also, right?
Yeah.
So like if you go by this way, what they are telling, I mean, let's say sum of first array is S1 and sum of second array is S2, right? This is what we have to prove at last.
Correct. Mm-hmm.
And now S2 you can write what? Total sum. I mean, S1 plus S2 will be equal to what? Total sum of the array.
Mm-hmm.
So this can be written as S of S1 and N2 can be written as what? Total N minus N1. Now
Mm-hmm.
if you multiply this N into S1
Mm-hmm.
minus N1 S1, this is equal to what? N1 into S minus N1 S1, right?
Mm-hmm.
So these two will be cancelled. Now N is equal to what? N1 into S upon S1. So this is telling you what? If you find N to be an integer, then you are done, right? If you get this value as an integer, because that means what you got N equal to 2 means what? One array will have 2 elements and the rest of the element will have any number of elements. Let's say if N you got as 2, then N no, no, sorry, N1 I'm telling, I made a mistake, like other way around you do. Your N1 will be equal to what? N into S1 by S, right? Just multiplying this and putting it in the division factor. Let me write it clearly. So your N is
what
equal
did
to
you
what?
multiply with?
Pardon?
What did you multiply with? I didn't get it.
Uh, okay. What I'm let me control.
So he's
See,
saying,
initially I wrote this equation N equal to N1 into S by S1, right?
Yeah,
yeah, yeah.
I understand it, but then there's a step you multiply. How did you
Yeah,
get n1
I
minus
put
n1s?
I cross multiply. I'm doing N into S1 upon N1 up this equation. Okay, I'll just remember that equation. What I've written N equal to N1 into S upon S1, right?
Yeah.
It
So
was
he's
S1,
finding
right?
average, right? So
Yeah,
N1 by S1 and N by S, they are going to be the same, correct? So that is an
yeah,
average.
yeah. So this is your N,
So
right?
how do you
Just
get n equal n1s over s1?
N into S. This is
So he's
N1.
saying, imagine like N is equal to,
N
okay,
into
N is a
S1 we
number,
are
right?
doing, yeah, and this is equal to N1 into S. Now this
Right,
S will go to the bottom. Simple like transformation.
right. So if N is the number of elements of the whole array and
Exactly, yeah.
S is the sum of the whole array, and if
No,
you,
one array.
yeah, so but if N is equal to the whole array sum, in this case
Hmm.
it is 8, N is number of elements is 8, so sum will
Yeah.
be 36 in that case, correct?
Hmm.
So if
Yeah,
you
correct.
sum all of them, and then
Yeah.
if you divide this array into two parts, maybe like if I take 4, 5, 1, 4, 5, 8, the first array. So
Yeah.
if I say the n1 is equal to 4 in that case, so s1 of that array will be something like 18. Okay. So
Yeah.
then if you say 36 divided by 9 is equal to 18 divided by 4, correct?
Four. Yeah.
So that is what is trying to prove.
So from here it's a subset problem. I mean, yeah, let's say N you got as something like 3, right? So you have to find 3 elements from this array whose sum is S1 and you are done. Remaining you can get S minus S1 you do, right? Because this
Exactly.
equation came only from when I made that N1 by S1 equal to N2 by S2. From there
Absolutely.
only. Yeah.
First, how do you get n over s equal n1 over s1? You
They
just
are
give
telling
me the equation, but
average,
I don't know where it come from.
average should be equal, right? Let's say it, S can be written as what? If I split into, we have to split into two arrays only, B and C, right? So this is sum of B and this is sum of C. And we have to, they are telling that S1 upon N1, like if N1 elements are in S1, this is the average will be what? S1 upon N1, and average of S2 will be what? S2 upon N2.
Okay.
Now S2, what you can write? S minus S1, right? And N2, what you can write? N minus N1. And if you cross multiply again, I mean, these two and these two, so you'll boil down to that equation. What do you say? So you can do here N into S1 minus N1 S1, and that will be equal to N1 S minus N1 S1. And these two get cancelled, and now you are left with N1 into S and into S. So this is equal to what?
Okay. Yeah.
Yeah. So that is what.
Yeah, so it boils down to like you can split the array into, you don't have to split it into equal number of subsets, right? You can split
Exactly.
into any size, right? So the way
Yeah.
this equation, what is representing here, n1 can be any value, but as long as he satisfy this condition, correct? So then we are good.
Yeah.
So that is what you're trying to say, correct?
Exactly.
Yeah.
I mean, the sum for this will get, and remaining, I mean, it's done. If you get any integer value, you found that one such array.
Yeah.
Yeah.
So the integer value, because you need to divide the whole whatever this ns divided by s1, it should be there should be no remainder when you are dividing it, correct?
Yeah. Because that is the number of elements.
Right. Yeah.
N1 is the number of elements, and it can never be in fraction.
Correct.
Yeah.
So if you are able to find that, then it means you are good, and then you can return true. That is what the whole
Equation
problem is
says.
about. Yeah. Yeah. The
Yeah, but
equation.
can I ask here, formula you just wrote have two parameters, yeah, S1 and N1. We need to find both of them, yeah?
Yeah, you have to find N1 such the N1 numbers in the array whose sum is S1.
Okay, thank you.
Yeah.
Okay. So how do we find it?
Now normal
We
backtracking
divide
you
the
can use.
n and time with the sum, right? And then that's a nominator.
Yeah.
We sum up the array, right? And time with the element with the length.
No, no, that will find using backtracking. Oh, you are telling directly to substitute in the formula.
Yeah.
Oh yeah.
So now
No,
if you
doing that?
so
but
if
how
you
you
look
get
at
so
this one, right? If you look at actually, if I try to say, so if you look at the whole thing, the average actually for this is 4.5, right? So this is a fraction number. So we need to actually find out any number, okay, which will be an integer value. So if I take average of two numbers, okay, and add up both of them, it will be 9, right?
yeah,
So in this case, if I find in this array, okay, and also this 9 will represent two elements,
5
correct?
plus 4. Yeah.
Yeah. So if I have two elements, and if I find in this array two elements which sum to 9,
Yeah,
correct?
done.
So then we are good.
Exactly.
So either we can find any value like 4 and 5, this is one subset, or 1 and 8, right? So because if we find 4 and 5, so the remaining values which are like 1, 2, 3, and 6, 7, 8, right? These all actually, if we add them and take an average of it, they will also be 4.5.
Yeah.
So that is what we are trying to prove. So we are trying to just find a subset like this or this one. So whichever we get early, so we can keep on incrementing our this count also. Similarly, we will have to add more of these, right?
Numbers.
Yeah.
Okay, so, and we use that equation that Shashank provide to find the 4.5.
Yeah, actually, that is what will give you the answer, the number of elements as well as the sum, what is required for those elements. So because if you have an average of 4.5, so the way he was doing it, right, n is equal to n1 into s divided by s1, right?
Yeah.
So if you use that, you will get the number of elements, the minimum number of elements with that average.
The minimum, in this case, the minimum number of elements is 2. And
Yeah, actually, it can be more, any number. I'm just saying minimum. So if you can find maximum also is fine, but then it will take long time, right? So you start with a smaller value, keep on incrementing, and therefore he's saying use a backtracking. So you start from 1, but 1 won't work. So you use 2, and for 2 you know that the sum of average, which is 4.5, will be 9. Okay, so you try to find 2 values. If that doesn't work, then you say 3. But 3 is average, and the sum will be 3 into 4.5 will be 13.5. So, but it's a fraction, you won't be able to find that number, right? So you skip 3. So you take 4 in that case. So it will give you 18. So you try to find any 4 elements in this array which sum up to 18. If you are not able to find, then go to 5. If it is 5, it is going to be fraction, then you go to 6. So as long as you are able to find any value, then you are good. And for finding that particular value, use the backtracking.
But you will not pass the test case. Really, it is hitting.
Really? Okay.
Yeah. Then I went and saw this DP solution that they are using. This is also the same.
But you will have to, you will have to
Mm.
memorize it, right?
Memorize it, yeah.
Yeah,
Without,
it's a DP solution, correct.
yeah,
So you can use with a backtracking, but you will have to do memorization in that case.
memorization, yeah. I'll just walk you through these many things. Okay.
I have a question if you don't mind me asking.
What?
So basically, how are you sure that there will be some overlapping subproblems? I mean, obviously the main recursion plus memorization is top down DP, obviously they're giving us that, but
So
how do we know that there are overlapping subproblems?
Yes, we'll take this, right? 1, 2, 3, 4, 5, 6, 7. This is our array, right? Now what we'll do, let's say n equal to, I got it from equation 2 and I have to obtain a sum of 9. Okay, then what I'll do? Let's say initially I'll take 1. Now my sum has reduced to it. I'll take 2 branches. I mean, all the possibilities I'll explore. Initially I got a number 1. So sum will reduce to it, right? Now second time I'll take 2 and the sum will reduce to 7. Now again I'll have here. So if you draw this tree further, somewhere you will find some of the sums are already repeating. I mean, those will be the sub problems you get.
Yeah. One more question I have is,
Okay,
so without drawing the recursion tree, can we identify that there are overlaps in these problems, in these subproblems? Because obviously in the interviews, we'll not be having that amount of time to draw the recursive structures and then prove them that there are overlapping subproblems, and that's why we are using memorization.
Yeah. So yeah, in that case, what you can do is, because you are going from value like the way he's saying from 1, 2, 3, 4, you are increasing, right? So whenever you do the recursion for the lower values, those values can be used for calculating the upper values also, right? So when you do something for the size of n, which is 2, and then you end up with recursion, you don't find a satisfactory answer. So when you come to a size for 4, you can use the same sub problems what you actually cached in for the number 2, right? Because 2 plus 2 will make 4, right? So that will be the overlap, right? So that way you can visualize. Yeah, I understand it's very quick. You need to visualize it and move ahead. So I would
because I mean, many of the people, if they know recursion, then they can write backtracking solutions. But
right.
To go from backtracking to use of memorization, obviously, if we submit that, we get the early, and then we understand that we need to memorize them. So that is one way I do that, but obviously that's not the right way.
Yeah, it's very important. Yeah, that's a good point.
So how would you go? Like, what would what you are suggesting, because recursion tree will give a clear picture, right? You can show to the interviewer that this is.
Yeah, but that is true.
Yeah.
But if he's saying that before even going that route, because
Yeah.
if you want to do a recursion tree, you are sure that it's going to have a overlapping sub problem, right? But just
Exactly.
first you will have to visualize whether it's going to be that way. Because if you draw the whole thing and you realize it's not possible, then you will have to you already spent some time in that, right?
Exactly.
So
Yeah. Wise
before
decision.
going in that, yeah, what is a very quick decision you can do? So, but yeah, you can think it this way and then draw it.
That
Yeah,
makes
it's
sense.
tricky part. So we'll have to keep on doing different problems. But for this, it's straightforward. It looks right.
Yeah, that's
Yeah, you can build up on the
Yeah,
lower
yeah,
values. Yeah,
it's pretty straightforward.
yeah. But
then
that's
comes
very good
practice.
point. For the next problems, we can actually visualize that way. Cool.
Okay.
Yeah, go ahead. Yeah.
Yeah. So this is like what is I'm using just memo for dict. I'm using what do you say for memoization, and this is your what length of the array and sum of the array. Okay.
Mhm.
And here that formula, just what I showed, that is working, right? S into
Correct.
j by n,
Mm-hmm.
and this will run for till the half of the array. I mean n by 2 plus 1, and this is just checking. And now let's say what do you say?
So that
Why
formula will give you the number of elements, correct?
elements there? Yeah.
Okay.
And you need to check for every combination of s and j that s cross j mod n this equals to 0. That means this is an you shouldn't be left with any remainder.
Right.
Yeah. Like what is it saying is the sum of the subset, and it should be an integer. So we only proceed to check if you find that this condition is what do you say? This
Yeah.
condition is fulfilled. Yeah.
So S multiplied by J should be completely divisible by N.
Length of the array. Yeah.
Yeah.
And just this will take you to this function. You have a target, and k is what? K is your like from wherever j. I mean that index.
Hmm.
Whatever.
So
I mean
basically, J is the length of the subset.
exactly length of the subset. You can. Yeah.
Yeah.
That is much more clearer. So this is your length of a subset, and these are some of the base cases that I'm using. Like if your length of this, I mean, subset is 0, then just check whether target equal to 0 at that point of time. If it is, then it will return true, otherwise false.
Mm-hmm.
And this is another one base case. Like if k plus I is greater than the length of your array, then again, definitely it's not possible to, what do you say, get the array with equal average, right?
Correct. Yeah. Mm-hmm.
And this is just normal memoization that we do in DP. These are the 3 states, and if it is already present in your memo table, just you return from there itself. Otherwise, what we were doing, like you take that particular element, subtract it from the target. Since you use that number, so you are reducing the size of your subset by 1 and go for the next iteration. I mean, this is the state, and in this state, I'm putting the whatever value I get out of these 2 calls. Like if I say
Yeah,
it's
so
a
basically it's a
knapsack.
choice.
Knapsack, yeah, choice. Yeah. Either you take it or you don't take it, and depending
Exactly.
on that true or false, you yeah.
And so you said you were getting a TLE, but you are
In
not getting a TLE because you actually took care of that multiple only memoization. Okay.
memoization, yeah.
So the memoization, the way you did on line 22, you are doing a memoization for the next state, correct?
Exactly, yeah.
So that is what you have to do here. You cannot do the normal memoization.
I think we can do, right. We'll have to change it then. I mean, for whatever state you are calculating, you put the value. That is what you are saying, right?
Yeah. Because
Yeah,
usually I do the template version.
that is good
I'm
to follow.
trying to
Yeah.
understand this. Yeah.
I think.
I mean, I think this is top-down DP.
It is
Yeah,
top
this
down.
is top
Yeah.
down. Yeah. Mhm.
See, in this type of DP, top down, one is actually you use a for loop, okay, or you use a knapsack way, the way you have done, right?
Yeah,
So
yeah.
if you use a for loop, I think in that case you memorize the normal way. I think,
Oh,
I'm not saying, yeah,
Yeah,
I'm not.
I mean, even in both of them, we can memorize. Even in top down and bottom up, we can memorize using iteration. In bottom up, I don't know if we can implement that in recursive way, but In both the ways, we can use a for loop to memorize rather than
Yep.
using a recursion. But yeah,
Yeah, but if you look at the
Both.
memoization, what you have done in this case, he has done it very slightly different, right? On the line 22. So, but the normal way would be like you say memoization of target K and I instead of going for the next state. Yeah. So that is what I was trying to find out if I use a for loop, will that memoization work? But because I was trying to do this knapsack way and I was getting some errors, so I just left in between. But then the for loop actually worked for me, so therefore I just kept it that way.
Hopefully
yeah.
that's good.
And one more observation is that this problem is similar to LCS. I mean, subsequence finally. Basically, even
Subsequent.
knapsack is also similar to subsequence. Yeah.
They are the same family parent. Just
Yeah,
different.
all of them exactly. So this OR condition will, I mean, yeah, the TP state or the backtracking. I mean, the creation of the sub branches. It's actually similar. It's the same code that creates the sub branches with the recursion.
Recursion.
Yeah, it's good actually to visualize the way you really feel comfortable about. Yeah, but only thing about the LCS part, it is slightly different, right? So the way I tend to remember LCS is like you compare two
String.
characters and all that, right? So then you have two different decisions to take care. But yeah, so
Yeah,
whatever is comfortable is always best for us to remember that way. Yeah.
Everything boils down to knapsack. I mean, LCS also, this also boils to
Yeah.
knapsack.
So when
Yeah.
he is saying, then it makes sense. Mhm.
So we can go through that for loop one.
Uh, okay.
You
It
want
is
to?
almost the same what you're doing, but only I'm adding. Okay, I just came to the wrong place. Just give me a minute. Okay. Okay. Just a minute. Okay, the knapsack. Okay. So yeah, I was trying to do this knapsack way, then it was giving me a TLE. I just left it. So this is the way I'm doing it. Um, everything almost is the same, but this is C++ code. So therefore you might be feeling it slightly weird, but yeah. So this is what you are. I'm using only one case, one recursion function. Okay, because in knapsack you will have to use the two of them, right? Whether you take a choice or don't. So in this case, this is the only condition I'm looking for. If it is less than or equal to the remaining value, then I just go in. Then I
Use it.
decrement my n. Yeah, that is the number of elements, and then my increase my index to the next value, and then remove the current sum. Right. So that is the only thing. And if you look at the state, what I'm setting, I'm just setting to the normal state, n-1. So n-1 I'm always taking because I started with here from 1. Okay, the size I cannot have 0, right?
Yeah.
Because you have to have at least 2 elements, right? 0 and 1. So that is the way it is, and trying to reduce it only till n by 2, because if you go more than half, it is going to give the same result. If you are not able to find within half, you won't find at all, right? Yeah.
That's interesting.
Yeah. So almost both are same. But so I was trying here, so then I got into issues. TLE, it wasn't working, so I just left it. Yeah. But there might be some way actually to handle it proper. I did not spend more time. Yeah.
No, then we can switch to next.
Yeah.
Okay.
Any
So
questions? Yeah.
yeah, if any question.
Okay.
Then next is our like push dominoes. So there are n dominoes in a line, and we place each domino vertical upright. So in the beginning, we simultaneously push some of the dominoes either to the left or to the right. So after each second, each domino that is falling to the left pushes adjacent dominoes on the left, and if it is on the right, it will push on the right. And when a vertical domino has dominoes falling from both the sides, and definitely it will be balanced in that case. Right, like this one, orange one. So this left is pushing right, and right is pushing this side, right? So it is a balance.
Yeah.
And for the purpose of this question, we'll consider a falling domino expends no additional force to a falling or already fallen domino. And now we are given a string S, where S of I mean, if it is L, that means towards the left it has been pushed, and if it is R, towards the right it has been pushed. And now if it is a dot, then it has not been pushed. It is a balanced kind of.
Yeah.
So string, we have to return the final state given this initial state. So yeah, so if it is a dot, right, and if it is L, so definitely we'll try to push this side. That's why this L is coming,
Right.
right? And for this right again, you have the dot between the left and the right. Right will try to push again this side.
Right will push on
This is
the
balanced.
right side.
Yeah, this is balanced.
So they all push simultaneously at the same time, right? On that input array. It's not like one by one, they all.
No.
Well, actually, it will be one
Imagine
by
that
one.
they all
right?
push at the same time.
Okay. So if
It's a
you take
snapshot, you can say.
if we take an example like this, right?
Yeah.
So what do you think what the answer will be in this case?
So
If I have only one R and they are about 1, 2, 3, 4, 5, 6, 6 dots means the size is 7. So what do you think this will answer will be?
all are.
Correct. So the output will be all R, right? So we'll have
Yes.
all 7 R's, right? So this is one way. And second, if I say another 1, 2, 3, 4, 5, and then L. So in this case,
Again.
what's going to be?
All in.
Yeah.
It will, because this will push that and it will
Yeah.
be carried on.
So this will be, and now if I just have something like this, 1, 2, 3, and L, and all 0 on dots.
So it will be 4L and then dot dot dot.
The first 4 L's, right? Yeah. So it is exactly the dominoes what we see, right? If we just fall it, make it give a force on the left side, it will fall to the left. So right side to the right. So now what he is saying, if you look at the explanation, what he says, for the purpose of this question, we'll have to consider that a falling domino expends no additional force to the falling or already fallen domino. So when we have n, like if we have R here and if we have R here, so when this guy is actually falling, so whatever the pressure he is putting here, so this guy's pressure is not going to increase, correct?
Yeah.
So if this,
I'm saying that, both are falling at the same time.
Yep.
That simultaneously. Not like, is it not like you fall, you push one R first and then later you push the second R.
It's like the same time. Consider it's happening in one snapshot. Like,
exactly at one, yeah.
So that's why, because they fall at the same time. So if you have one fall to the right, the other one fall to the left, and then the middle one will be, stand still.
Balanced here.
Yeah, it will balance, correct. So when you have one which is dot and you have equal number of R's and left across, at both sides of it, then it is going to hold it because the force will be the same on it. So it will nullify. Yeah, makes sense. So that is the only key. So you still have to find the force of the very extreme right or the extreme left and then keep on adding them, right?
Yeah.
And the middle too. But anywhere.
Anywhere, yeah. So wherever you find it.
Right, extreme left.
Yeah.
So
I mean, it has to fall at the same time.
Yeah, it has to fall at the same time. But when you are trying to construct your answer, you will start with one element, right? Wherever the R or left is, and then you will keep on doing that for maybe just R's and then lefts, and then you can combine the answer, something like that.
Yeah.
What do you mean? Like, can you give an example?
No, I was saying like you
Only
said, right?
one.
If we take an R, okay. So you first do evaluation of R's, then you do evaluations of L, and then you actually aggregate all the results, right? So
Yeah.
imagine first you just have R's, then you imagine just you have L's, right? In the case when you had these one dot, and then you had
Yeah.
something in the center,
Let's
right?
go with example one. How would it work?
So if we had R like this, if we had this one, and then we had another dot and L, right? In this case, what will happen? So this R will exert a pressure on this guy also. This L will exert a pressure on this guy. But when you come here, the pressure from R, okay, and the pressure from L will be equal, but they are in the opposite directions,
It will
right?
balance each other.
Yeah. Therefore, this guy in the center will be balanced. So you will have R here, okay, and then you will have L here, and this will be a dot
So
because
if
it is
it
standing still.
odd in length, it will always be balanced, right?
Oh yeah, so the odd length it will always be balanced, and if it was an even length, we would not have this dot here, correct? So if it was like this, right? So in this case, it will be I'll just draw it here. It will be R and L, right? Because now the force has whatever the force it is exerting between these two R and L, right? So there is no spot here, but it is between R and L, so it is standing here. This R and L are actually they are making it stand together because they have equal forces, right, or in opposite directions.
Yeah.
So let's say if the input string is like that, RRLL,
Uh-huh.
and the output, what could it be?
Okay, so you are saying what is the input string RR and LL like this?
Yeah,
This is
the
balance only.
output will be the same, right?
It has to be the same, yeah.
But in this case, which one we push first? Is that the extreme? We have to do it all at the same time, right?
Yeah,
Snapshot, that's why, like in one time span, everything will happen.
But
correct.
and then somehow we do and we say, okay, it cannot fall.
Yeah,
Can fall like
but
that?
he's saying that you cannot fall these ones, right? Because now uh, they both all are balanced. But
Balance.
anytime whenever you say you can do it at the same time, it you can visualize that, but when you have to implement it, you still have to start from either the left side or the right side, right? Because this is an array, you'll have to access it, and then you have to traverse the whole array and then find all the forces.
Yeah, I was thinking if we can do it at the same time, if like, not sure. For example, we do the breadth-first search, right?
Oh, okay, you are attacking the graph way. Yeah, that might
All
be a
the
possible
time.
way of implementing. Yeah, yeah, there might be very different ways to implement. Absolutely. Hmm. Then in that case, you can do it. So you are trying to say if you do it the breadth first way, so you take all the levels at the same time, whatever each one is exerting, and then move to the next level, and then find what the levels will be at that. Yeah, you can imagine that, right? I didn't try that. Yeah, but that is a one way of thinking. Yeah.
Okay, so you do it one at a time, and you do from left to right.
Yeah, that was a easy way out of this solution. But yeah, BFS is there. People do it BFS also. You're right. Yeah. So, but
So in BFS, how do you go?
well, BFS actually they look for the pairs. It seems there's one Python implementation. Yeah, I didn't go through
I
it.
think
Every lab initially put all the in the input array, You
Mm-hmm.
put all that
Yes.
left or right along with the index to the queue. You have
Okay.
a queue size, right?
Mm-hmm.
So kind of like you search in multiple at multiple sources at the same time.
Oh, okay, okay, okay. Yeah, yeah, the multi-source BFS, right?
Mm.
Uh-huh. So you take all this whatever you whenever in this example one, see when you have LR, LR, and L, right? So these are the four sources for to start with your BFS. You put that in a queue. Okay, so at each level, you will look for you will take one of them L and then see where it actually going to go. So then you update its next level. So in this case, it will update the 0th L, right? So if I just quickly draw here, uh, so so this in this example, if we take right, so what I will do is I will pick up the first L, put it in my queue, the second R I will put in the queue, then I will put this LR, which is a combined one, and then L, right? So then when I come in the first level, when I'm actually in my level order traversal, so I'm at the first level, I will pick up this L, right? So now I know in this input where my L is. It is at the extreme uh, left position, right? So now this L will have an impact only on the previous L, right? So my formation of this will be instead of dot, I will now have two L's, correct? So then I go to this second R. Then other than that, I'm not going to do anything, right? So the second R actually left is that side. So R is going to have an impact on this position and the second position, right? So it's not going to go further because it's only at level one, right? So now I come to this LL. So in this LL, actually I think it is balance. No, it is going to fall other way, right? So I have already existed one. So I have another dot here, and I think yeah, that's all. So then I
It
have
will.
LL and RR, right?
Mm.
Sorry, RR. Then will have one dot. Okay. Then I have another L after that. So therefore this L, right? So when I'm done with this, so I will have another LL here, and I think I will have two
Single
dots
dot.
after that.
Mm. Okay,
Have
sorry,
a
two
trade,
dot.
yeah, yeah, two
Collapse.
dots, yeah. So I'm done with this level, but when I'm done with this level, actually I'm going to push this in my queue, these parts, which are actually between these dots. Okay, so now my first level queue is done. Okay, so then my second level queue will have this first element, this will be a second element, and this will be a third element. So then when I come in the level order traversal for level 2, okay, so these will be my inputs 1 and 2 and 3. So then I will again try to expand across this.
LL triple R it will be.
Yeah,
No,
something
this
like that. Yeah,
balance.
might be I did it the wrong way. I think R has to come here, right? So I made
Mm.
some, yeah, so it should be here actually instead of here. Yeah, it should be one dot. Okay,
Yeah, this side. Okay.
correct. So right should fall on this side. Yeah, something like that. Yeah, but it should be that way. Hmm. And then when you go for the next level, you take this input and then again try to expand it if you have any expansion scope, or then if you feel that it's not going to expand, so you're not going to put any of the elements in the queue, and then you can end your VFS, the level order traversal basically. Hmm.
So the first one, you are separating based on the dots, right? Top
Yes, yes,
one.
yeah.
So, okay. So, okay.
Whenever you have a group, you just
Mm.
actually separate them. So the first L actually goes there. Actually, R should have been this way, correct? Yeah, this was the R. So I will have this as the first element, then this will be the second element, and here also I made a mistake. It should not be any dot over here. So this will be the whole thing. So we are almost at the end of our traversal in this case because we don't do more. So it will be done within only one level. Correct, because after that, if you come in the level, next level, if you take this is the first LL, this is the second RR, right? And this will be the third because you don't have a dot here, right? So if you just remove this dot, okay, and this dot, So then you have 1, 2, and this will be a complete one. Yeah. Then you go to the next level, and then you won't be able to do anything there. Yeah. Yeah, that's a good one actually. Yeah, but the way we were discussing was a different one, right, Shashank?
Yeah.
Yeah, the most
2
simplest
points
way, right?
from left to right, right to left.
Okay. So can you explain that?
Yeah, yeah, sure. I'll walk through it simple on the code only. I'll walk.
Okay.
Make more sense. Yeah, so these two ways, like, I mean, first, whatever the Dominoes is there, I'm just making a list out of it based on everything, yeah. And filling all the, I mean, distance vector is there, you can say, like whatever the length of this input is, those many zeros will be there. This is the distance, right? And this is the right distance, which I've taken initially as none. Now I'll enumerate through that list, that the corresponding index and the value. If the value is your R, then R distance will be 0, right? Isn't it? Because right side, it will fall. It will fall on the right side. And if your value is L, then your R distance becomes none, because on right side it will not fall. So right side will be empty, right? Like if you have this R, right? Initially it was none, nothing is there, so I'm putting none. But when I see R, that means it will occupy this place. And in that place, now if it is L, then if there is a dot on the right side, then it will never occupy this. It will always fall on this side, right? So this will remain as it is none. And if your R distance is not equal to none, then we increase our R distance plus by 1. And whatever R distance you have to that index, at that particular index in our dist, we put the R distance. And this is like from the back. Yeah, go ahead.
No, that's correct. Yeah.
Yeah. And now this is like from the back side, I'm tracing that. I mean, from the back of that, whatever list I generated, this Dominoes. So you have already filled, for the front side, you are filling all the R, right? R and its distance.
Okay, when you are saying front side, you are actually going from your left to right, correct?
Right, yeah, exactly.
Okay.
And back side, I'm going the other way around.
Yeah. So when you are going from the left to right, yeah, can you scroll up a bit?
Sure.
Now I'm getting that. So when you're going from the left to right, so it means your left will only fall to the left side, but R will fall to the other side.
Other
So
side,
whenever you find an R, okay, so that value, the next value will be R.
Yeah.
Okay.
Wait. Yeah, go ahead.
Right. So whenever you find a value R, so your next value actually will be R.
Yeah, because it will fall on the right side.
Yeah. And
So
that is the
initially,
reason you are doing
all
that.
the dots were none. Yeah.
So all of the R distance or whatever the val are, they will all be none. Okay.
You can also see the LST.
Okay.
So this is, wait, let me delete this first. So this is our status, initial status. Let's copy this and then we'll compare. So all the left side, you will find that it's empty, right? Wait, let me print both the list, then I think that will make more sense. This is that list. And if I print the initial list, it will be. This is our initial list. Yeah. So what you can see this nothing will happen to this because it is on the left. And so here you are seeing the R, so it will fall, it will make it R. Then again this R will fall, will make this as R, right? Again,
Correct.
this R will be there, this will make it as R. Now this is a left. Now this is left, so it will fall on this side, right? No, I mean, I'm not doing anything with the left now. Simply, I'm just considering the forward pass, like only the right part.
So whenever you get any L or R, you just stop there for the previous R where what you are coming with the domino effect.
Coming, Again, this R will occupied by this R. This R will push this R. Here also you'll have R, and now you will not have anything this side because left will never. Now I'll go the other way around, like from back side. I mean, I'll traverse this from this side.
Right to left, okay.
Yeah, so this is what I'm like. If the dominoes is L, then L distance will be 0, and if it is R, then you don't need to do anything. You make that distance as null, right? And here just we are comparing if the left distance is less than the distance at that current position. So this is for the which dot is stable, right? Like here, this side is left and this side is right. So they are not consecutive, right? So whatever here, this will remain as a dot itself.
Okay. So that will be okay. It's equal pressure of both sides. Okay, no problem.
Yeah, equal pressure. Yeah. Then we'll put the dot. So I think this is for checking the odd, right? I mean distance, like okay, like here you have left and here you have right. Both are at the equal distance from this dot, right? So this dot will remain as at its place without any.
So it is trying to find a force at each and every location. So it's trying to find a force. If your R force is greater, then your R will come. If your left force is greater, then left will come. If both forces are equal, then it's going to be a dot. Yeah.
Some indentation.
Yeah, so best case would be one way of looking at it is if you use some sort of values, so then they will actually be very clear, but it will involve more implementation, right? But you are trying to do it a very smart way, right? So it's a more efficient way because that's what the way the code has to be implemented. But for the explanation, it is always good to have some values which will show you the exact pressure or the force on each and every point from the R side and the left side.
Both sides,
yeah. So this is the way you are doing on the now left side, right? The second one.
Second one.
The last
one is original. First one is original, yeah. Second one is right, and third one is the left.
Yeah.
Yeah.
And the last one is your answer. That will be the complete answer.
Yeah, left and both are combined. Yeah.
Combined together, right? Yeah. So you can't visualize because now you see here, in this case, right? So you have 4 R's, right? And then you have an L. Now what is happening is now your L is coming here, right? And then it is coming here, but now your R has gone in this dot, right? So it cannot be because the reason is your L is putting a pressure. Maybe this is a pressure which comes 2. With this pressure comes maybe, okay, I'll just make it a bigger number like 3. So this comes 2, right? And these are all the negative forces, right? If we consider for now, and here it will come -1, right? But if you come from 3, it will from R, it is going to be 3. Then it will be 2 because we are decrementing based on it. And then we come here, it is okay. We lost Shashank. Hey Shashank, are you back? Just let us wait for a couple of minutes. He'll be back.
If he doesn't come in like a few minutes, I'll go ahead with the other problem, the maximum subarray problem.
Yeah, just wait. Let him come because I think he'll drop. Yeah, he's coming.
Okay.
Usually it happens for him in the morning.
Okay.
Yes, Shashank. Hey, are you speaking? Or not able to hear you? Because he was displaying that, right? Yeah, that was important to understand. Hey, Shashank, we are unable to hear you. Oh, I think I need to make him the host. Okay, in the meantime, I'll just go and share the screen. Okay, so let us see what. The Dominoes, right? Okay. Yeah, so this one actually, yeah. Okay, so in this case, if you come here, so what he was saying here, actually, yeah, that question was a different one, I think, right? Because he was having a different
Yeah,
input. Yeah, you're back? Okay, yeah, go ahead, share it. Because we are actually looking at that test case, right?
exactly. Yeah. So let me share it.
Mm-hmm.
Actual context. Yeah. So this one. Yeah.
Yeah. The only thing is, I was trying to understand this one, right? So, this point, why this is actually becoming dot, because earlier it was R, correct?
Yeah.
So, the way I was trying to understand is because the way you are coming from here, okay, the R, you are actually equally putting a pressure force on this point, and the same thing what you are doing with the L also in this case, when you are doing in the second in your this the right to left side, correct?
In that.
Yeah, therefore it actually nullifies and therefore you get a dot here, right?
Yeah.
That's the only thing actually I wanted to make a point. But rest everything is the same, right? There's not going to be have any difference.
Yeah.
Yeah, this is pretty clear, right? All the three of them. So you
Yeah.
have the input, you have the right, left to right, and the right to left.
Left in that case. Now we can move to next.
Yeah.
So next is like again Cadence algorithm. So maximum subarray given integer array num. So you have to find the continuous subarray which has largest sum and return its sum. So this is that, right? 4 minus 1 2. And if you have figured out a solution, try coding another solution. Okay, which is more subtle. Fine. So this is like normal Cadence algorithm that we are using, right?
Yeah, I would actually go that route. That is because at least we know it, and
Yeah.
it is also not an easy to remember most of the time. But yeah,
Exactly.
yeah. So
When you
that is the
say
best we can do.
cadence algorithm, what is that algorithm? So basically, are we taking? So let's say on that input array, are we taking? So let's since the question is asking find the contiguous subarray which has the largest sum and returns in sum. Contiguous means they're adjacent to each other. Are we saying, okay, let's check -2 and 1 first? What's the sum? and then let's check -2, 1, and -3, and -3 by itself. What's the sum? Is that how that algorithm works, or?
It's bit more optimized. I mean, that would be like a brute force what you are saying, right? I mean, all the possible sub arrays you are checking. So here we'll make a decision, right? I mean, it's like initially, let's say minus, like I'm initializing that this is my maximum, right? Now when I go to 1, I'll add -2 plus 1, and I'll take only 1. Now which one is better? This will give you -1, right? And this will give you 1. So it's better to start a sub array from 1, right?
Yep. So that's what I was saying. Yeah. So basically, so is -2 and 1 better, or 1 better by itself?
1 is better. Yeah, exactly. Okay.
Is -2, 1, and -3 better, or -3 better by itself? So we're just continuously checking that and moving forward. And as we're checking it, we're also keeping track of our maximum sum on that contiguous subarray. And whichever is the maximum, we're returning the maximum. Is that how that algorithm works, or?
When you reach 1, no, we don't check for -2. Now I'll check like this. Till now my current sum is 1, okay, because this is the best sub array that I've obtained. Now I'll check whether 1 is better or 1 plus 3 is better. I won't check for -2. I mean sorry, this is -3.
Right.
You were
Right.
checking
So
for -2 here.
no, I was up. So if once we find out that, let's say on that example, right? So if we do 1 and -2, 1 is better, so we'll pick 1, right? Now if we check -1, -2, 1, and -3 better, -3, which one's better? So it basically comes down to 4 is better. So once 4 is better, because everything, then we will start checking from 4 onwards. We'll leave the rest of the left.
Yeah, exactly.
Yeah.
Discarding all those sub arrays.
Exactly. But that algorithm you're talking about, is that how that algorithm works, or?
Yeah, it works that way only.
Okay.
At every step you check whatever the current sum you have obtained. To that you obtain the current number, and you check your number. Whichever is max of them, you start your series from there.
Okay. Yeah. No, I did the exact same way. I couldn't know. I didn't know that was the name of that algorithm. Yeah.
You discovered it then.
Yeah. Yeah, I guess. Yeah.
That's cool. Yeah.
Yeah. Yeah. You want, you can. Okay. Let me then. Mine is same, like, so what I'm doing initially, my maximum ending here is first number, and maximum is also the first number I'm taking. Now I'm going from 1 onwards, right? So this is what I'm to the whatever current sum I've obtained, to that I'll add the current number, and I'll take the current number, and I'll check which one of them gives the max. So whichever is max, I'll just update my global, what do you say? I mean, I have a global variable as a maximum.
Right.
So maximum ending here and the max, whichever is maximum of them, I'll update.
Yeah. I did the exact same way, just in Java. Yeah. Same logic.
Oh, that's awesome. Let's go through that.
Okay.
Well, okay. Yeah. But what about the follow-up, what they are asking?
No, that's a good one too.
Right. Yeah. I just trying to look at that. So why they are asking a follow-up when we have an optimized solution?
Yeah, the divide and conquer approach will work for n log n complexity, but the cadence algorithm, yes, the cadence algorithm is O of n.
Okay.
Then why we are going for divide and conquer? It will be n log n, right?
No,
Yes.
log n is saying.
No, n log n.
It will
That
be
will be n log n, but they just want that whether you can actually think about or divide and conquer for this problem.
Yes. Yeah. Praveen said right.
So the reason is because everyone knows the cadence algorithm. Now they want to move.
Yeah, exactly.
Exactly.
Okay. Okay.
So for that, then again, normal, like you'll divide the array first into 2 halves, right? These 2 halves.
Right.
Yes, for the divide and conquer approach, we need to divide the array into 2 halves. Then we need to find the max algorithm for both the halves, and also we need to consider the mid element, and then take the maximum algorithm in both the halves which we considered. So there will be 3 sums, and we need to choose maximum of all the 3 sum.
Mm-hmm.
Left sum, right sum, and the sum including left plus right plus the middle element.
Yes, yes.
So how do you do that? I understood
Okay,
the divide part, but then
okay.
when you come
I'll
to
just
this,
Okay.
this is the example array. Uh, so the size is one. So the size
can you be a bit loud? I think, is it?
the size is the length is 9, I guess. So for the first iteration, the mid element will be 5. So for uh, 5, will have 3 sum where we will be including 5 and then max where sum in 1 to 4 plus max logarithm from 5 9. This will be first sum. Then for the second sum, we will be taking only this one, and for sum 3, we will be taking the last. No, it will be comes to 9. And then we will return max of all the 3 sum which we calculate. So these two will be a recursive call using the only implemented. But the first one, where we will be including the mid element, we have to calculate this part. So for this part, here we will be using some approach of cadence algorithm again.
Okay, so you're going to use the cadence algorithm there.
Yes. So in the implementation, this is the base case where we need to set the pointers uh, for which interval we are calculating the value. Then we will be dividing that interval into 2 halves. Then for each of the 2 halves, we will be calculating, which will be a recursive call. And then in the left side and in the right side, again, we have to calculate the, no, here we need to calculate the max prefix and max suffix part.
Not the cadence algorithm, just the
Yes,
prefix.
yes, max prefix and max suffix part, and we will be including the middle element. And at last, we just need to return the max of all the 3 sum which we calculated. So in the explanation, for 5, uh, no, the fifth element is -1. So we will be including -1 in the first one, and the max subarray sum in the range 1 to 4 will be starting from here. So 4, first we will check if we can include 4. It is maximum, so we will include it. Then you will see 4 plus -3, it will be 1. So it will be 4 here, and here it will be 1, then 2, and then 0. So here we will be choosing only the maximum prefix part, maximum suffix part. So 4 will be included. Again, for the right side, we will start from 2. So 2 plus 1, 3, minus 5, minus 2, and 1, 4, 2. So the max one is 3, so we will be including 3 here. So here this one will calculate to -1 plus 4 plus 3. So the first sum will be this value. Again, these two parts will be recursive call. So again for these two sub arrays, we will be calculating this again. So this was since we are dividing the array into half. Each time we are dividing the array into half of the size. This is why it is divide and conquer approach, and later we are choosing the maximum of the all the values.
No, one doubt. What is that -1 in someone?
This is the middle element, like in this array,
Oh,
middle
got it.
element.
So
But
if it is
actually,
even, if
yes,
the size is even,
Then it's just implementation, I guess. It will be 4 here.
okay.
one of the sub array will be odd. Okay.
Average
It
of
will be L plus R by 2.
Well, actually, Praveen pointed out it's not a Kadans algorithm, right? The way you are implementing in that.
Yes, for the left side, we are taking the max suffix sum, and for the right part, we are taking the max prefix sum.
Okay. Okay.
Since we are including -1, so it has to be contiguous.
Hmm.
This is why here in the left part, we have to take the suffix, and in the right part, we have to take the prefix.
Makes sense. Yeah. And then when you add that, both of them together, along with
Yeah,
that middle
middle
element
element.
also, right? Yeah. Then you return it.
uh, this problem is similar to sliding window maximum. Something we use the same concept of that max from prefix and suffix.
Sliding window.
Maximum. One problem is there.
Oh, you go from left to right and right to left, right?
Kind of. No, yeah, and the same concept what is telling prefix max we are taking and suffix max. Those
Hmm.
concepts.
Hmm.
Yeah.
Okay.
But
Yeah, we should.
but since uh, this part is uh, again recursive call is done for half of the half size of the array, so
Hmm.
this will be this part will be big of n, and again the recursive calls will be around log of n, so n log n will be the time complexity. Since the both the halves can be divided into log of n subarrays in total. And for each of the sub-arrays, we again need to iterate in the whole sub-array, since we are including the middle part again. So this is why n log n.
Yeah. Hmm. Hmm. So the only important thing is calculating that mid prefix sum, correct? Prefix and suffix sum. Hmm.
Yes, in general recurrence questions, we calculate the maximum of both the halves, but here uh, with the both the halves, we again need to consider the whole sub-array also.
Hmm. Yeah, makes sense. In the worst case, it should be able to do it, right? The way you are explaining it should be possible to implement. Yeah. But we might need some help from the interviewer in that case if we haven't seen this implementation earlier, right?
Yeah.
Yes,
Mm.
I think even if we try to guess it directly, then we could have come to this part only, uh, like calculating the max sum for both the halves and taking the max of the both. This including the middle element, I don't think everyone will come up with this
Yeah.
instantaneous.
Yeah. But I think the way Shashank is saying, if we had earlier the sliding window problem, if we would have done that, then using that algo, sort of, yep,
We can.
yeah. Maybe try to imagine that way.
Yeah.
Yeah, yeah, but that's good.
Yeah, very interesting solution.
Yeah, it looks very simple now, though, but it's not.
Yeah.
Yeah. Suppose
Yeah.
you wanted to share your algorithm.
Yeah, it's the
That will
same
be
as
good.
Sang. It's just in Java, but I'll share real quick. I'll
Yeah.
explain too.
Let's learn the language and
All right.
interdiscipline.
So let's see. So the intuition was something like this, right? I'll paste the intuition first, and we'll go after the code. So, all right. So the question says, given an integer array, nums find a contiguous subarray containing at least one number which has the largest sum. Right? Continuous means okay, it has to be next to each other. And so my idea is, all right. So let's move. Let's start the first index, and let's move and check. So that's at first let's move. So we'll keep a true counter, and both counter points to -2 first, and as we're moving along, we'll keep on adding it. So what happens? Okay, -2 and 1, we moved along. -1 now, which is greater? Should I? So basically it's asking us to find the largest sum and return its sum, but it's also saying that I could have containing at least one number. So my subarray can have just one element. So I can say, all right, if I make my subarray just 1, and if I make my subarray 1 and -2, which one's better? Obviously 1 is better, so we'll take 1. Now we'll move along. We'll check, okay, if I take my subarray -2, no, if I check my subarray now we will disregard this -2 because it's no longer, we can't and use them. Right now we'll have to check from -1 and -3. So same thing. If I check if I take -3 by itself, and if I check -3 and my 1 by itself, which one's better? Obviously, um, -2 is better. Which means obviously 1 -2. If taking these both subarrays is better. So we take both of them in this case, right? Let's move along. Same thing is, if I take 4 by itself better, or if I take 1 plus -3 plus 4 better. Obviously 4 is bigger, so we'll take 4 by itself, right? Similarly, we'll move, and go all the way to the end. But if you notice on this numbers, I'm also checking, I'm also keeping track of, okay, which one is giving me the maximum? 1, -2, 4, 3, 6. See, I have the maximum. We just need to store that maximum, and we have our answer, right? That's the intuition. Now let me bring the code and prove that. So, all right. And the code does exactly the same thing, right? It points max current and max result to the first element, and then it loops, right? Do a ON loop. It keeps track of max current, and this is what I was talking about. Math.max nums I, max current plus nums I is taking, if I take 1 by itself better or 1 -2 better, that kind of thing. And then and once I find 1 better, now it's going to compare. It's going to disregard -2. It's going to, if I take 1 better, it's the same thing I explained above. That's what this line number 22 is doing. As soon as I get my biggest element, which we do when we get here, 6, we will get our maximum element. So basically, when do we get our 6? We will get our 6 right here when we're checking 4 -2 to the right here. When we're doing this will give us 6. And at that point, it's, we will have our 6, and we will store that in our max result array. And then we will return our max result. But this, forget about the problem, but this intuition, this approach, it's so usable. You can use this in later future solutions, like the solution that we saw earlier, right? The intuition. So yeah, that's what I'm going after. So hopefully it makes sense.
Yeah.
That is right. So you said that this can be used in what other areas?
I have to explore problems on that, but
Okay.
basically the
Yeah.
intuition, right? The
Yeah.
idea, how we are moving along, this is very
Uh-huh.
useful. We can make helper methods out of this and do a lot of stuff. So yeah,
Okay.
it's yep.
Yeah, but that's a good observation. Yep.
Mm-hmm.
Because
Yeah.
it's very hard to understand this Kadan's algorithm, right? Initially, when you
Yeah.
first look at it,
Yeah.
yeah,
Th-
it's very
That's why I
easy to
did this,
understand.
because it's harder for me too. So once I figure this out, then I'm like, okay, that's what he was talking about. Yep.
So the way you implemented here, you are actually trying to compare your max current with your, if it is greater than the max result, right? Then only you include that. But
Mm-hmm.
in some cases, what means usually I tend to do is, if I look for my max current, if it is less than zero, then I make it zero. Yeah.
There are two
Okay.
implementations.
Oh, really? Okay. So I
Yeah.
I never saw this. It means okay. So
Yeah, so
the
Sapal,
second.
The one you are
intuition
mentioning,
what
if
you
it
are,
is negative, you
yeah,
make it
Sapal,
0.
so the intuition what you are talking is maybe, okay, may apply to the problem. There is a problem, gas station problem.
Okay.
Oh, yeah.
Oh, all right, let's check it out. We don't have to do it right now, but maybe you said gas station.
Yeah, the problem number. Let me tell you the problem number, and you can 135.
All right. Yeah, we're not gonna take maybe in the future session, but
Yeah,
okay.
you can try that by your.
Okay, I'll take a look. Thank you.
Okay, that works over here, Praveen.
Yeah.
Okay.
Yeah. All right.
So,
I mean the intuition, not the algorithm, but the intuition.
Exactly. Yeah. Yeah. Because that's what I get out of it, right? This problem comes and goes, but the intuition stays, right? So if we can memorize the intuition in the interview, we're good.
Absolutely, yeah.
Yeah.
just see the likes. 10K first question I've seen. I mean, more than 10K.
Oh, because everyone knows now Kadan's algorithm, therefore it has gone high.
This is a very old problem.
Yeah.
53 number, right? Yeah. 10,000. But people are still disliking it. So that's...
maybe 8-9 years ago, that used to be a hard problem.
Yeah.
Might be, yeah.
Because now
I think
everybody
Leetcode is also not that old. Hardly 4-5 years, I think Leetcode is.
Really? I thought it was pretty long.
I'm not sure, like.
No, it is like 5 years, yeah, maybe around there.
Yeah.
It wasn't that many questions also. It was like 300 questions before. Now it's like 1700, I don't know, it's keep on increasing every day.
Yeah, it is
Every
increasing
Sunday.
every week, yeah. By at least 4 to 5.
I think it's popular because every week they do have contests and there are people around who actually creating problem every day.
Stop my share.
I think it is the populist one, right, nowadays, at least till now, as per the ranking.
Yeah.
Shall I stop the recording, Shashank?
Yeah, sure. Yeah. It's a 2017 person.